I've just completed step 4 and 5 in the last video. And one thing I forgot to do was to save my map as step 5. I've saved it as step 4, but not step 5. So before I start on step 6, I'm going to save as and change it to step 5 and click save. I'm going to clear the projection of my data frame just in case. In this case, I don't think I need my toolbox anymore. I'm going to be able to see a lot more of my data now. In this step, I'll demonstrate a new tool called Clip and refresh from Lab 2 joins. And we're going to join the spatial data and non-spatial data so that the PhD dataset, which is non-spatial at this point, can be displayed on the map. We'll often use the clip to resolve the issue of a dataset being too big from our area of interest. In this case, I'm going to clip Tacoma Shapes and use a cookie cutter that is the file Tacoma proper or layer. I will also clip the city of Tacoma, but I could clip almost anything as long as it expands beyond the boundary. So let's go back and I'm going to clip Tacoma Shapes. So first let's zoom to the layer Tacoma Shapes and I'm going to turn everything else off. And notice Tacoma Shapes has this area that extends out into the narrows. And if I turn on Tacoma proper, we can see that the area in blue extends beyond the area in aqua. So I'm going to use the aqua as a cookie cutter to clip out Tacoma Shapes and create a new Tacoma Shapes. I can find the clip tool by going up to geoprocessing. This is a frequently used tool, so it's up here, and choose clip. If you can see the show help button, please click it. You should always have the show help open. And this is a perfect tool to demonstrate why. Input features. It's tough to remember, is this the cookie cutter or is this the cookie dough that's about to be clipped? In this case, it gives us a visual. The input looks like the cookie dough. And I had said that I'm going to clip Tacoma Shapes. I find Tacoma Shapes and then the clip features. If I can go click in this grayish bluish area to go back, the clip feature is Tacoma proper. And I'll give it a name. And in this case, I'm clipping Tacoma Shapes. So I'll find Tacoma Shapes that's projected and then change the name from projected to clip. Or I could try to add on the word clip to the end of the file. Let's try that. It seems to be not too long, so that'll work. Completed, there's clip. I can zoom to it and turn off the other layers. There's Tacoma Shapes project clip. I should clear the projection of my data frame. Make sure everything lines up. So there's Tacoma proper and city of Tacoma. They're all about the same size now. It is not the big area of Tacoma Shapes. And I can remove Tacoma Shapes because I don't need that anymore. I have the Tacoma Shapes up here. So that was a quick clip. I'm also going to clip the city of Tacoma. So let's turn on the city of Tacoma. You notice that it expands beyond the border of Tacoma proper. So I'll use Tacoma proper to clip it again, to clip the city of Tacoma. I go to clip. The input is the bigger one, city of Tacoma. The clip features are Tacoma proper. I'll give it a name of City of Tacoma Project 10N clip. Save. Okay. It is added to the map. I can remove the old city of Tacoma. And because they're two different colors, it's very hard to see. So we'll change them. There we go. Now they're identical. I'm going to clear the projection of my data frame. And I'm noticing as I do this that they're still all coming from Data Quiz K3. All of my data is ending up over here. I'm getting quite a bit of data. Now a join review. We are going to join the Tacoma Shapes and the PhD dataset. Now let's turn on Tacoma Shapes Project 10N Clip, and we'll have the dataset. For this, I suggested you open an attribute table. Let me bring this down so you can see. This is the attribute table of Tacoma Shapes, and the PhD dataset I'll open. I then drag one of these to the side so that they're in a vertical tab group. Because the PhD dataset has less columns, I'm going to use that to decide which is my unique key. It's never OID, it's never FID, by the way. It couldn't be the number of residents or the PhD holders, and definitely not the median income. It has to be area key. So once I know that it's area key, I can quickly search through Tacoma Shapes Project 10N to find a column that looks nearly identical. They're two different names, but those are the two that are the same. And notice there's 191 here and 178 there. For this little exercise, it does not matter. So GeoID and area key. When doing a join, you always start with the shape. I choose joins and relates, joins. It was GeoID and then area key. I'm going to validate the join. And then there's 178 records. I complete it. And now all of the information from the PhD dataset is added on to the end or appended to Tacoma Shapes. The one step that I must remember to do though is to export this layer so that I make the join permanent. So I'm going to data, export data, send it to not my quiz 2. This is where I would have an extra line, but to I always have to double check. Go to my quizzes, quiz 3, data quiz 3, and I'm going to call this Tacoma Shapes join. Save. And it's added to the map. And now my data is appended to the end. If I open up the attribute table, and I'm going to symbolize by PhD holder just to very quickly symbolize. But first, I'm going to clear the projection of my data frame. Click apply. And now I'll go to properties in symbology. I'm going to symbolize by quantities, and the value that I'm looking for is PhD holders. I'm not in this case going to normalize. I am going to pick, let's say, a goal. Well, we'll just use purple because we're UW, and we're looking for a darker purple to be the most PhD holders per area, and the least being a light purple because there are some people that hold a PhD. And this data is coming from the census. Under label, I'm going to show you a quick trick of formatting labels. I'm going to say numeric, but 0 decimals. I don't need any partial PhD folks. So now it's going to show 0 to 83, etc. I'll move this out of the way so we can see it apply. And then OK. So here's a very quick symbolized map of non-spatial data that was made spatial by joining it, and then symbolization. The last little item of this demonstration will be to find data online. And in this case, I'm going to download school data from the Pierce County data portal. So let me pull in my Firefox, and I'll just Google Pierce County data portal. And Pierce County GIS data portal looks good. Open in a new tab and go to that tab. And I want schools. And here I found a layer, schools, last updated last month, 294 records of schools in Pierce County. This tells us a little bit about the data. Here are school grounds, which we don't want. We want points. So here it will tell us it has an address, the district, the grade. And we can see that it's points. In this case, we could click here on the data to look at the data. And in fact, from here we could download, or we could go back to the overview and click download. And we almost always download a shapefile. I click download. It's preparing. You notice it's moving. And a schools.zip file is about to be downloaded. I'm going to save the file. And let me minimize this window so it's easier for you to see. Save it in my directory. Quizzes, quiz 3, raw data, school zip. And I can now close this window. Navigate to Windows, go to my directory, quizzes, quiz 3, raw data, and there's schools. I right click, open with, Windows Explorer, click the extract button, extract all, take away the last folder, click extract. And now it's extracted. I'll close these windows and refresh my raw data if necessary. So there's the school's point. Let's look at the properties because we need it in the proper coordinate system. The coordinate system is NAD 1983 Harn, Washington, South, foot, US. So that is not our desired coordinate system for this lab. I'm going to click OK and turn back to my toolbox. It does have spatial information, so I need to only project. I go to project, and schools is not in my map, so I must look for it using the folder, which is fine. Quiz 3, raw data, schools. It tells me the coordinate system. I'm going to change this so that it is school. Let's do Pierce schools, and then we're going to call it project 10N. Save, and the output coordinate system is my favorite. And click OK. And notice it does say now geographic transformation optional, but it's not giving it to us. It's not optional. This is required. And this is where in the directions I've given you specifics of what to put in there. I'm just going to copy it now and paste it for you, but you should save this. Always use this one when you get this item when you're going from Harn to non-Harn in NAD 1983. So again, this is in the directions. I just copy and pasted it. NAD 1983 to Harn, Washington, Oregon, and click the plus. And this says error, invalid transformation. It seems as though it doesn't like this transformation. I'm going to highlight and delete and just leave that caution. Just try it anyway and click OK. And it appears to work. We'll look into that a little bit further. Peer schools, bring that over, and it does work. I'm going to close Arc Toolbox again to give me more room. And let's do one final clip just to practice. Geoprocessing, clip, and we're going to clip the peer schools by Tacoma proper. We'll call it Tacoma Schools Project 10N. Okay, close. I will clear the projection to make sure everything's lining up. I'm going to remove peer schools, and the only schools I have now are in Tacoma. So there's a clip. And I'm done with this video lecture. I'm going to save as, make this step 6. Save, and at this point I would save my final map. So let's do that. Save as, give it a AAA. Let's say this is my final map, which it should not be. Quiz 3, final, save. And there's the Quiz 3 final. I'll also save a PDF while I'm at it. File, export map. Choose the PDF 300 because I'll probably print it. It copies over the same name, but notice it was going to go to Quiz Y, which is bad. I need to go back to quizzes, Quiz 3, and make sure it goes right to my maps folder. And now I've got it in there. It doesn't show up, but it definitely is in there. Now I'll save my map one last time by clicking save, and then just close before I zip. And that concludes step 6 and 7. One last note I should mention, if this were a lab, I would end up zipping my user ID in Windows, not the big Quiz 3, just the user ID. And last but not least, the written response. What is the projection? The projection for Tacoma schools, or excuse me, peer schools, that was an interesting one. It was up on the screen, but I didn't show you very long. NAD 83 underscore Harn underscore Washington South. I'm just going to copy that so I have it. That was the original projection of the school, so I knew I had to project it again. And that's the end of the Quiz 3 video lecture.